So this is another example calculation using the Henderson Hasselbalch equation. But this time we're going to use it in a slightly different context. So in our previous examples on slide 11, 16, and even 25, our buffers have consisted of an acid and its conjugate base. But we can also make a buffer out of a weak base and its conjugate acid. And so when we do that, we have to make some slight modifications in how we solve this type of problem. So for our Henderson Hasselbalch, the equation still remains pH is equal to pKa plus log of my base over acid. Now, in this context, we can think of base over acid, where base could be some B, generic base like ammonia, and our acid is going to be the conjugate acid of our base. We can represent HB+. So slightly different meaning between acid and base than it was in our previous examples where we were using a weak acid and its conjugate base. So our problem that we're looking at on slide 27 of our chapter 18 PowerPoint says to use the Henderson Hasselbalch equation to calculate pH of a buffer solution that is 0.5 molar in ammonia and 0.2 molar in ammonium chloride. And they give us, that's actually a typo in the problem, the pKb. That's not the Kb. And I apologize for that. I will go back in and change it. So notice that we're only given the pKb, but our problem, our Henderson Hasselbalch equation, which we'll be utilizing, we need pKa. So we can use this equation that pKa plus pKb is equal to 14 to basically use our pKb that we're given to find pKa. So, if we rearrange this, we can say that pKa is going to be equal to 14 minus my pKb. And if I substitute in the value given to me in this problem, which is pKb is 4.75, I get that 14 minus 4.75 gives me a pKa of 9.25. So now that I have my pKa, I can substitute it in to my Henderson Hasselbalch equation, along with the molarities I'm given in the problem. So pH is going to be equal to pKa, which we just solved for, 9.25, plus log of my base. In this case, my base is ammonia, and it's got a molarity of 0.50 over my conjugate acid or acid component, which happens to be my ammonium chloride, which has a molarity of 0.20. So now, if we plug these values in, get 9.25 as my pKa, and I take the log of that ratio, I get 0.40, and I can solve and get that my pH is 9.65. So very similar setup to our previous problem, just now we're doing it in the context of a basic buffer composed of weak base and its conjugate acid.